Thank you, Justice. So we're going to talk today about a smart sprinkler controller that I built with Nerves. And as Justice said, I'm Todd Resudek. A little bit about me. I'm a senior software engineer at Weedmaps, and I'm a member of the Hex core team, the dumbest member of the Hex core team. You can find me on GitHub at Super Simple and on Twitter at Super Simple without the vowels. So follow me. I always like to meet new friends. So yeah, as Justice pointed out, I'm in the enviable position of presenting right before lunch. So in case the food arrives early, I just want to show my most important slide first. That's the cutest cat. And all right, now that we got that out of the way, we can worry about the rest of this stuff. Okay, so what is this project all about? So this is the future. So this is the sprinkler controller built with Nerves. And since it's the future, I call it the Drizzle 2000. And you can come up and check it out after the talk, and you can see all the wires and stuff. So I'm really glad I'm giving this talk in Austin, somewhere in the Midwest or the South. I think if I was giving this talk in New York or something, or San Francisco, I'd probably have to spend a lot more time explaining what a sprinkler system is. But I figure you guys down here probably know this by now. So lawn sprinklers, that's what we're talking about. So first step is, what is a sprinkler controller? So it turns your sprinklers on and off. It usually follows a preset schedule. And it independently controls multiple zones. So if you think about it, you have your front yard getting water at some point, and then your backyard gets watered at another point. And those are controlled independently. But is it customizable? So most of us, I know for myself, when I bought my house, the sprinkler controller that was in my garage was definitely not customizable. All right, so if you want a smart sprinkler controller right now, there are some off-the-shelf options. And one of the really popular ones is this Rachio. This is the Rachio 3. It's their 3rd generation. And this one controls 8 zones. But it's $229. So, honest question, why wouldn't you just buy one rather than to build the Drizzle 2000? So the first, yeah, all right. So the first big thing is the cost difference. You're cheap, or $229 is a lot of money for some mechanism that's going to sit on your garage wall that you never look at. And mechanically, it's actually relatively simple. So yeah, you want to save some money. It's fun. So honestly, like a lot of us probably sit around building things on screens all day, and then we turn off our screens and it doesn't exist anymore. And so sometimes it's fun to actually build things with physical components and to learn something new. So even though a lot of us are not hardware engineers, it's always fun to dig into some new space and just learn new things. All right, so I'll show you my credentials, why I'm up here telling you how to do things. So this is a brief history of my experience with hardware. So this is number 1. It's called Stall Monitor, and it's open source. So, okay, a little backstory on this. If you can't tell, this is the inside of a bathroom stall. And there's a microcontroller there, and you can see the wires. And there's a little reed switch that's connected to the lock. So it'll change its state based on whether the lock is on or off. And so this little microcontroller just updated a web API or every time the state changed. And I wrote a little system bar app for OS X that would show an icon whether the bathroom was being used or not. And this was born out of a real-life need. And I don't work there anymore, so I can be honest about it. So our CEO, when building out this really expensive new office, decided, oh, we have 100 men that work here. How many bathroom stalls do you think we should put in? 1. 1 sounds like the exact perfect number. And since they cater lunch every day, most people eat lunch, and then they're still at the office after lunch, yada, yada, yada. So it ended up with a lot of people queuing up, I guess, near that area. And so this was a technology solution to a real-life problem that I had. I'm still waiting for the call from the Nobel Committee for this. And they'll get around to it. And so after departing that job, I worked at a place in Boulder, Colorado, which is, parking is a little bit of a situation there. And we had 2 assigned parking spots at our building, but we had 4 people that were driving in every day. And the street parking was far away from the office. So if you go to the office and those 2 spots are taken up, then you have to drive back 15 minutes to find the street parking. And so this is a project I call Parkr. And it's just a little box. That antenna there is for the Wi-Fi, since the parking spot was kind of far away from our Wi-Fi router. That gave us extra range. And then a sensor there, a sonic sensor that detects range. So when you pull into the spot, it detects that there was an object within, I forget what the sensitivity was, but it could tell that, okay, there's a car here versus there's a person walking by. And again, this would update a web API so that while you're driving in, you could see if anybody had been parked there yet, and then that way you could save the time of going there and then having to find street parking. So yeah, I mean, these are kind of what looks like trivial things, but they're actually solving real problems in my life. All right, so when I got started on working on sprinkler systems, so again, this was born out of a problem that I had. The sprinkler controller that came with my house, sorry, if you haven't bought a house, a lot of times what they do now is they'll put in a front lawn but not a back lawn. And they'll put in front sprinklers but not back sprinklers. And so since my front yard only had 3 zones that it needed, they put in a sprinkler controller that could handle 6 zones, which is pretty much the minimum you could buy off the shelf, like the cheapest one you can get. So unfortunately, when I went to go finish my backyard, I needed another 5 zones. And so since I have a 6-zone controller, and I need to support 8 zones, I had to get a new sprinkler controller system. So that's kind of where that was the genesis of this project. So the first thing was to see, like, how do sprinklers work? Is this something that I even could build? So if you go to your sprinkler system now, first step is your power supply. So it's plugged into the wall, big block, and for just about every sprinkler controller, this is going to put out a 24 volts AC, somewhere between 24 and 30 volts of AC. And that goes to this controller box, which is usually a little plastic box that's mounted on the wall. And it's got a timer on there. You can see the clock. And then those pluses are the zones. So basically, there's wires that come out to control each zone. All right, so those wires are connected. Power goes out to a valve box. The valve box looks like this usually. It's a green or black box that's kind of sitting in the ground. And if you take that cover off, what you'll see is a bunch of tubes where there's water, and then a bunch of wires, which are those wires that come from your sprinkler controller. So you've got wires in one side, electricity in, and water in the other side. And eventually, those go out to your sprinkler heads. So every zone is going to have 3, 4, or 5 sprinkler heads on it. So that's the basic gist of how the system works. So it's a pretty simple electromechanical system. And so I felt pretty confident that this is something that I could build myself with nerves. All right, so each one of those zones acts as a relay. So when it's given some voltage, it will close the relay circuit, and that's basically lets that power from the power brick go through the wire to that specific zone that it's trying to turn on. And so there are solid state relays, but I'm using mechanical relays. And basically there's that yellow thing is an electromagnet, and the red and the black represents the circuit that would be going from the power supply and then out to the valve box. And so when you apply a little bit of voltage to the electromagnet, it pulls that circuit into place, and now the 24 volts is essentially going right out to your valve box. Inside the valve box are valves, and that's why they call it a valve box, I guess. And so each zone has a valve on it, and this, again, is a really simple electromechanical device. And so it has a solenoid in it, and it has water that goes through it. And when the solenoid doesn't have power, it has a little plunger that blocks the flow of water, and when you do apply power, it pulls the solenoid up and pulls that plunger out of the way so water can pass through. All right, so let's start building. So the parts required for this is basically a Raspberry Pi and a relay board so that, sorry, we lost battery maybe? All right. Check, 1, 2, check, check, check. Okay. All right, I feel like Kanye maybe? I don't know. MAGA. Oh, boom. All right. All right, sorry. Is this working okay? Can you hear me back there? Okay. So the blue board there is a relay board, and as I said, the relays are the things that control the power to the valve box. So Raspberry Pi, memory card, a relay board, and then some random wires. So the Raspberry Pi is between $10 and $35, depending on the speed that you want. But honestly, the $10 one will be just fine. Power supplies, so you need a 5-volt power supply for the Pi, and you need the 24-volt power supply for the controller. It's likely, if you're replacing another controller like I was, you already have one of those power supplies. And if you're like most people, you probably have a whole drawer full of 5-volt power supplies already. But if you don't, 15 bucks. The relay board, $9. A memory card, $6. And I think as Justin pointed out yesterday, your whole application is going to be 30 megabytes. So you don't need a big memory card. You probably just find the smallest memory card that you can get at the best price. And some random wires. So once you get into Nerve stuff, you're going to find that you have this whole menagerie of weird wires and sensors and other stuff that you got from eBay that you don't even know what it does yet, but you saw Frank had it once and you thought maybe it was cool. All right. So we've got our parts. Let's talk a little bit about the design of hardware. So this is what I try to keep in mind when I design hardware. It's a quote from Mitch Hedberg. So it says, an escalator can never break. It can only become stairs. And so, if you look at the Drizzle 2000, you'll see that it has these switches on it. And the idea behind the switches is that I was going to say if, but I also should say when the program that I wrote starts to tweak out and then my sprinklers don't come on anymore. Worst case scenario is I can go here, I can manually flip a switch and turn a zone on. And so in that case, that is my escalator becoming stairs. And so right now we're used to having the world at our fingertips, and so our user interfaces that we use for web work are very, very complicated. And in hardware, you don't have the benefit of multiple screens. Everything is there. And so if you're not careful, what you end up designing is this, which is the cockpit of a helicopter. And you probably look at it and you know what everything does, but anybody else that's looking at it is like, dude, I just wanted to water the lawn. And so I would be more inspired by something like this. So this is a really great piece of hardware that acts as its user interface and can do some very complex things with a very limited number of controls and buttons. And so sometimes your mind will run wild, and so paring that back into its simplest form, thinking like DITA-ROMs is important for this. Intro on Nerve. So I'll go over a little bit of intro on this, but I think Justin covered a lot of this yesterday, so I'll probably go through it pretty fast. So Nerves is this entirely new way to build embedded systems using Elixir, and it's specifically designed for embedded systems. So it's not for desktops, it's not for servers. Usually you could think of it in 3 parts. So there's a platform, there's the framework, and there's the tooling around it. So you put them all together, and what you get is something really, really powerful to build embedded devices. The compatible hardware, again, Justin, I think, pointed this out, but basically any Raspberry Pi that was ever built, plus any BeagleBone that's around. All right, so I've done other hardware before and written it in C. So why would why would we want to use Elixir? So first, it's easier to write. If you don't know C, or you put your C days behind you, you know, this is a benefit. So you can write all this stuff in Elixir now. It's more features. So you now open up the access to OTP. So now you have you know, agents that you can work on and gen servers that you can use. And you know, you can do a lot more advanced stuff than I can do with C. Maybe some smarter people can do them with C. And libraries. So there's a big open source community out there that is producing libraries that, you know, allow you to not even have to write a lot of code. So installation, I'm going to breeze through this a little bit, but you know, suffice it to say, nerves requires a number of programs on your system. So first, this is for Mac. There's a similar setup for Linux. Get nerves going on your machine, update Homebrew, install a few low-level libraries on your system, then go in and install Erlang and Elixir, and update your hex and your rebar. And then this is where the magic happens. So install the nerves bootstrap archive. So once you got that, your nerves, you are ready for nerves. All right, so let's do this. So this is where the rubber meets the road. This is actually how the sprinkler system works. So step one is the zones. So as I mentioned, I needed 8 zones in my lawn. And so first step is to configure those. So all this is a simple map to say zone 1 is connected to pin 7, zone 8 is connected to pin 14 on my Raspberry Pi, so on and so forth. And you might think, like, why did you pick such random numbers? And I think you'll find out if you haven't done any nerves work yet that those pins are actually all in one row in line. So it makes absolutely no sense here, but when you look at the Pi, you'll find that those are all adjacent pins. All right, next step to a sprinkler controller is the schedule. So we've got independent zones, and now we've got a scheduler. So in this case, I'm setting up, OK, Sunday, zone 1 is going to run for 20 minutes. And on Monday, zone 2 is going to run for 10 minutes, so on and so forth. So I've got a list of zones and durations. All right, step 3. Let's start running things. So let's add a couple of modules under a supervision tree. So let's init this project, which is called Drizzle. Let's initialize it. Let's set up the scheduler, and let's build today's events. So in the init module, first thing it's going to do is register each pin from the config. So you told it which pins you want to use. And in nerves, you have to essentially register those pins so it knows how to communicate with them. And then after you register the pins, let's set it to its default state. So in this case, we're going to deactivate the zones. So when it sets up, its default state is all zones off. And registering a pin is really easy. So you loop through all the pin numbers. And in this case, it's just saying, go out to the GPIO module and open up pin number X and set it for output. So in this case, we are reading from the pins, the state from the pins. So we're setting it up in a unidirectional way. All right, the next module is the scheduler. So first thing we're going to do is let's go get that schedule that we set up in the config. Let's set up our days so we can refer to days of the week as atoms instead of numbers. And since we're going to be dealing with time, let me set up my UTC offset. And yeah, so I'm -7 at my house, so I set that up. And this is what the bulk of the code in the scheduler looks like. So it's basically designed to call itself every single minute. So once a minute, it sends out this work process or this command to the work process and to execute any scheduled events. And so executing the scheduled events, it looks like this. So first thing it does is checks if the current time is 0. So if it is midnight right now, or midnight at my house right now, or if the current state of today's events is an empty list, go ahead and reset the state and set up for today's events. So at midnight tonight, this is Saturday, so at midnight tonight, it's going to go ahead and reset everything that I had set up for Saturday's events and set up Sunday's events. Or if I'm turning it on for the first time, it sees that it's an empty list, and rather than wait till midnight and start working tomorrow, it looks at today's events and sets those up. So it's quite simple, I guess, quite simple process. And so it goes through each event and says, okay, if the event time is the current time, then process that event. So in this case, if the event is telling me to turn on a zone, do that. If the event is telling me to turn off a zone, then do that. And that, again, is just really simple. So we're, in this case, we're writing to a pin, telling it either to turn off or turn on. All right, excuse me. Today's events. And so this is where we're storing state. So we're building up state for each 24-hour period when we do this. So either at midnight or when the system turns on. And so today's events is an agent that stores a state, and it takes the schedule for the current day of the week, and it is going to build a list of events. So events look a little bit like this, and so it starts at, in this case, a very simple controller. This is always going to start at midnight, and it's going to look at all of its events, or a list of events. It's going to say, okay, well, I'm starting at 0. Let me build an event. Let me add the duration. So it's watering zone 1 for 20 minutes. So it adds 20 minutes to its accumulator, gives a minute of a buffer zone, and then, sets up a stop event, then gives a minute of a buffer zone, and then it'll go to the next event. So in this case, it's saying run this for 20 minutes, wait a minute, run the next zone for its duration, wait a minute. And the minute buffer is just a factor of physics. So you need time for the water pressure to build back up in your system, and that's why there's a little bit of delay from one zone going off to the next zone going on. And since the precision of my gen server is running once a minute, in this case I'm giving it a minute to buffer. In real life, it could be much faster than that. All right, so what we just did there was build a very dumb smart sprinkler system. It starts at midnight every day and waters for those durations. So let's make it smarter. So first thing is, let's set up for different times of day. So I want to water my front lawn both in the morning and in the evening. And I want to water my front bushes or my flowers in the afternoon, for instance. So instead of starting at the events at midnight every day, let's pick some times. So in my morning watering events will happen between 5 and 8 a.m. My afternoon will happen between 2:30 and 4, and so on and so forth. And now let's update the tuples in the scheduler list. So in this case, we're going from a 2-tuple to a 3-tuple. So on Sunday, zone 1 is going to run in the morning for 20 minutes, and then it's going to run again in the evening for 20 minutes. And then in between that, I've got zone 2 running in the afternoon for 10 minutes. And since we're going to make it smart, I live in Colorado, so I'm going to set up some winter months. So I know that in the winter, I'm not going to be doing any watering at all. So let's set that up. So these 4 months, I'm going to essentially deactivate the system. All right, and let's add a couple of new processes to the schedule or to the supervisor here, and one for the weather data and one for a forecaster. So what are we going to do here? So the first one is we want to initialize the weather data with 12 empty hours. So, and then we're going to push the next 24 hours to the list. So weather data is going to store a forecasted weather from a weather API. And I don't only want to know what's going to happen in the next day. I want to know what has happened recently. And so, for example, if it rained an hour ago, if it rained an inch, I want to know that so that I can make my sprinklers smart. It's not important to me. It's not only important to me that it's going to rain an hour from now. I also want to know what happened recently. So we're building up 36 hours of state, essentially, for weather data. And in order to do that, I'm going to set up my latitude and longitude. And I'm going to add this hex library for for Weather API. In this case, it's dark sky. And let's move on to the forecaster. So the forecaster goes out and it schedules itself to update once an hour. And once an hour, it's going to go out and get the newest weather report. And part of that, to make this smart, is we're going to create a weather adjustment factor. So the weather adjustment factor is going to be how we're going to alter our watering schedule based on the data that we know from the weather. And so first step is, look, hey, are we in one of the winter months? And if so, our weather adjustment factor is going to be 0. So effectively, turn all the durations to 0. Otherwise, go out, get the weather info, including the low temperature, the high temperature, and the precipitation information, and then do some calculations on it to calculate the final factor. So this is the weather info, and it's pretty messy. And so low temperature and high temperature are easy. Let's get the forecasted low. If it's in the freezing range, that's going to be important to us. If it's really hot, that's important to us. And then let's catch the rainfall. And in this case, we want to find not only the amount of rainfall that it's forecasting, but we want to find the percentage chance that that's going to happen, so that we can calculate an algorithm based on that. So if it's forecasting 10 inches of rain, but it's saying the percentage of that happening is 1%, we want to do a calculation that's a little bit different than if it's 2 inches of rain, but it's 100% chance that it's going to happen. And so again, like I said, with the weather, we want to set up a low temp and a high temp. So in this case, I'm saying if it's 40 degrees or below, I want to treat that as a special case. If it's 90 degrees or above, I want to treat that as a special case. And so my temperature adjustment, which goes into the weather adjustment factor, looks at those numbers. And so if the low is below 40, zero it out. I'm not going to water on that day. If the high is above 90, I want to multiply it by a factor of 1.33. So I want to extend my watering times on hot days. And anything else, just multiply it by 1. And the precipitation adjustment, as I said, looks at both the likelihood of the rain happening as well as the amount of rain that's supposed to happen, and does a similar calculation. Based on the amount of precipitation forecasted, adjust the times by X amount. And so if you hit the 1.0 mark of rain, drop it down to 0. So it rained enough that we don't need to water our lawn today. And let's go update today's events. So before we were starting at, well, first let's go get the factor. So the factor is the accumulated factor from all of our sensor data. So in this case, we've only applied weather forecast and temperature to it, but we could also do other things. So let's first get that. And for our start time, let's look at that map that we made of available watering times. So instead of starting at midnight, we're going to start our morning watering at 5 a.m. in this case. And then the only other update here is in the accumulators. So we're going to start with the start time, and then instead of using the duration directly, we're going to use the duration times the weather adjustment factor. So 20 minutes on a hot day becomes 26.6 minutes. All right, so now we have a smart or smarter sprinkler. And so we want to burn our firmware. And again, Justin covered a lot of this yesterday, so we'll kind of breeze through it. But essentially, you want to set your target, which is your device. You want to initialize a release if you haven't already. Get your dependencies, build your firmware, and then burn your firmware. And so what that usually looks like is you've got a memory card in your computer or probably in your dongle, and you've burned it to there. And that takes 2 seconds, and then you move it over to Drizzle 2000, and now you've got updated software. And in the old days, what we used to call this is sneaker net. So rather than Ethernet, this is sneaker net. So you're taking data on a disk, and you're running it over to so-and-so, and you're giving it to them. And so that's really cute, but it's not necessarily smart. Does anybody know who this is, by the way? Shout it out. Derpy. Thank you. Whoever that was, you're my hero. This is Derpy Hose from Friendship is Magic, MLP. So if you want to learn more, hit me up on Twitter, and I'll tell you the whole story. I've already bored some of you with it. And so in our dependencies, so let's get a little bit smarter with our process. So Drizzle 2000 is out in the garage. And I'm not going to run out to the garage every time I want to update the firmware because I'm lazy. And so we have this Nerves.Init gadget library already, and it includes a lot of useful tools. So first thing, let's set up SSH. So let's tell it where to look for my public key so that I'm the only one that can update this. And let's set up some DNS stuff. So in this case, I'm using MDNS so that I can access the Drizzle 2000 with a local address rather than having to remember its IP, or maybe its IP has changed, been reassigned by my router. So we configure MDNS, which I always think of this when I think of MDNS. Like, yeah, so. And then let's set up the Wi-Fi. So in this case, we're setting up on wireless. And let's try it again. So now we're ready to burn. And instead of doing mixed firmware burn, we're going to do mixed firmware push and give it the MDNS address for Drizzle 2000. And so now this bad boy is going over radio waves. And so now it's cute and it's smart. So this monkey has 3 PhDs. Sorry, ape. He's an ape. All right, and boom, we're done. Sprinkler system completed. All right. Yeah, again. All right, so next step. So this is kind of just the beginning for Drizzle 2000. It's smart, and it's actually just as smart as the Ratio controller that you could pay $229 for at this point. But we could make it better. So Frank Kumro, who is here, he did a great talk last year at ElixirConf on building a local weather station. So instead of going out to dark sky and figuring out what the weather is like in my city, why don't I have a local weather station, and I'll know exactly what the weather is like at my house. So you could hook that up. You could hook up additional sensors. So in this case, I didn't show the code for it, but I've got a soil moisture sensor. So you can put that in the ground, and I can figure out exactly how dry or not dry my soil is, so I know how to adjust my watering. And infinity possibilities. So yeah, for Drizzle 2000, it's open source. So I welcome any pull requests on it. Go to my GitHub page, super simple to find it. So I'd like to support more sensors. So just like the soil moisture sensor, also like a photo sensor to tell how much sun is applied to different areas of the lawn to make adjustments there. Wind speed sensors, so that if the wind is blowing too far, you can pause the scheduler during that, the windy time, etc. A touchscreen interface would be nice. So using a maybe Scenic UI to be able to go up to Drizzle 2000 and be able to reprogram it or see its state through a touchscreen. Or a web or mobile interface. And then step 5, obligatory, that, and then I'll be rich. So next year I'll be showing up here in my helicopter. All right. So I couldn't have done this by myself. So I just want to say shout out to some people that helped me with this. So Michael Reese and John Karstens, who are my friends from the remote meetup, Nerves remote meetup. So at Nerves Meetup, if you guys are interested. And Jeffrey Matthias, who helped me with make the sticker for the Drizzle 2000. And then all the Nerves project contributors, so including Frank, Justin, and Greg, who are here, and, as well as Connor, and everybody else that contributes to Nerves project. And I'd also like to thank Weedmaps, who paid for me to be here and pays me to do these things, as well as Jim and all the organizers at Lonestar for inviting me to be here with you. Thanks.